Okay, so here's the first step in the review. It says a 300 milliliter solution of 0.850 molar ammonium phosphate is combined with 150 grams of solid lead 4 nitrate to create a reaction. The first question that I'm going to answer in the first video is going to be what is, or write the balanced chemical equation of the reaction above. Okay, so here we have, clearly we have two compounds. So one of them is ammonium phosphate, and the other is lead 4 chloride. Okay, so we're going to go to our periodic table of ions here to help us figure out what this is. Okay, now remember that we have to turn this into a chemical formula. Okay, so the periodic table of ions is going to be what's going to help us get us there. The first one is ammonium phosphate. I know because I've studied my ions that both ammonium phosphate and ammonium and phosphate are both polyatomic ions. Sorry, I got a little tongue-tied there. So because these are polyatomic ions, I'm going to look on the table up here that says polyatomic ions. Now, ammonium is here and phosphate is here. Okay, so I'm going to take a look at those two. I'm going to write the chemical symbol for each one. So for ammonium, the chemical symbol is NH4 plus. And for phosphate, you can see that it is PO4 3 minus. Okay, now once I have my chemical symbols, I'm going to go ahead and do the fish. This one comes over here. This 3 comes over here. And then I form a compound NH4 with the 3 here, and then PO4. Okay, now let's do the same thing for lead 4 chloride. Okay, so lead is an element. It's not a polyatomic ion. It is right here. Okay, and then chloride is not a polyatomic ion. It is an element and it is there. Now, as you can see, lead can either be a +2 or it can be a +4. So how do you know which one to use? Well, the name itself tells you which one to use. In this case, it says we're going to use the 4+. So that's what we're going to do, right? So the chemical symbol for lead is Pb. And now that we know because of this 4 that this is a 4+. The chemical symbol for chlorine is Cl. We know based on the table of ions and its position on the periodic table that it is a -1. Now, we're going to do the same process again. We're going to go ahead and do the fish. This 4 moves over here. This 1 moves over here. And we're going to form the chemical compound, which is lead chloride with a 4. Okay? So, there is the first half of the reaction. Now, I've seen a couple of you guys try to balance this out. You cannot balance this, guys, because this is only half of the reaction. You only have the reactants. So in order for us to balance the equation, you have to write the equation, which means you need the products, right? You need to have the products in order to have a balanced chemical equation. Now, what are the products and how do you figure those out? Well, I can see based on the compounds here that this is a compound here, AB. This is CD. So this tells me that I'm going to have a double replacement reaction, right? Double replacement reaction says that AB plus CD produces CB plus AD, right? It's basically just taking these two guys and switching them around. So because I know that it's a double replacement, I know that the products that form are going to be based on this model. That's how the model works. It's there to help you and to guide you to figure out how to predict the products for a chemical equation or a chemical reaction. Now, here's how we set this up, okay? I'm going to scroll this down a little bit. All right. Now, we have our AB and we have our CD. So let's separate everything out so we can figure out products, right? So I'm going to take my ions and I'm going to separate them again, okay? So that's going to be NH4 plus, okay? That's going to be PO4, 3 minus. Okay. Then I'm going to separate my other two. 4 plus Cl1 minus. Why am I separating everything? I'm separating everything because I don't want you guys to fall into the trap and saying, oh, this is a 4, this is a 3, this is a... I'm going to carry everything over and just use the same numbers again. You can't do that, because if you do that, then there would never be a need to balance an equation. You have to reset everything. So in order to make this work, I'm going to just rearrange everything, okay? And redo the fish every time. So once again, here's my A, here's my B, here's my C, and here's my D. Now, according to the reaction, right, on the left side or on the right side of the equation, I should recombine C with B, right? And I should recombine A with D, right? That's what the model says here. So let's set it up so we have the correct things rearranged in the correct order. So here we're going to take our C, which is PB, 4 plus, and then I'm going to take my D, which is Cl1 minus, right? Okay. Now I'm going to do the same thing with the A and the B. My A is NH4, 1 plus, and then my B is PO4, 3 minus. Okay. Now, all of these things should be combined. So here's what we have figured out so far. Okay, we figured out that it's going to be a double replacement reaction. We started off with AB plus CD, and once we figured out it was a double replacement, we went ahead and rearranged it according to the model, which says that C bonds with B and A bonds with D, which is basically saying that the positive ions are going to just swap places, right? That's exactly what we did. Okay, so now that we have it set up, now we can go back, do the fish all the way across, and get all the compounds with their correct subscript. Okay, so let's do the first one, which we already did at the top. It's going to be, let me see here. Let's see, it's going to be NH4. I'm going to do this actually in one color. So we have one unified equation. So NH4 PO4. Okay, this is the result of doing this fish, which we did earlier. That's going to combine with the compound that we found earlier, which is lead 4 chloride. That's going to result in these products, which I'm going to redo the fish here. Remember, polyatomic ions keep their subscripts, right? Because it never changes. So that 3 is going to move down here, and then that's going to combine with phosphate, which is a 4 here, and then I'm going to do the fish here. These are both 1s, so they're understood, and I don't need any subscripts. Okay, so there's our equation. Now, this equation is not balanced. All we did was we figured out what products are going to form, and then we formed them. So now let's balance the equation. So if I look at the right side will tell me all the elements that are involved. Remember that polyatomic ions should be treated as single elements because they don't separate. So make your life easier. On the left, I have 3 ammoniums. On the right, I have 1. On the left, I have 1 phosphate. On the right, I have 4. I have 1 lead, 3, and then I have 4 chlorines here and 1 here. Now, we can start with the ammoniums. We can start with the chlorines. It doesn't matter. I always like to start with the one that has the smallest amount of atoms. For example, if I look at the 3 and the 1, that's a total of 4 atoms. This is a total of 5. This is a total of 4. This is a total of 5. So I'm going to just go ahead and just say, you know what? I'm going to start with the ammonium. Okay. All right. So let's go ahead and start getting this one balanced. Okay. Now, I know that I have 3 ammoniums on the left and 1 ammonium on the right. So I'm going to add a 3 here. Okay. me add a little bit different colors so it stands out just a little bit more. So I'm going to add a 3 there. Now, when I do that, I'm going to update this value to a 3, and I'm going to also update this value to a 3, right? I can already see that this is not going to work because these numbers here are not going to line up. But let's keep going, okay? All right, so now let's go ahead and do the lead for chloride, right? So I'm going to add a 3 here to balance this out, okay? That's going to make this a 3, okay? And that's going to make this a 12. So you can see that's what I meant when I say it's not going to work out, right? So let's go ahead and let's erase this one. But you know what? We'll keep going. All right, I have 4 phosphates and I have 4 phosphates. So let's go ahead and put a 4 here, right? That's going to give me 4 phosphates, and then that's going to update my ammoniums to 12, right? So here we are. Now, what we have left, right, is I remember I told you that that one wasn't going to work. And that's possible, guys. Sometimes that's going to happen. So let's go ahead and erase this subscript, right? And let's update it, right? There's no rule saying that we can't change a subscript once we add it. So I'm going to go ahead and change this to a 12 because obviously that's what's needed. Whoop. Okay. Let's put that plus sign right back over there. And then let's put in that 12. Okay. Now, that's going to change my ammoniums to 12. And that's going to change my chlorines to 12. So now those are balanced. So now let's go back and let's double check. Okay. I have 12 ammoniums, 12 ammoniums. Okay. I have 4 phosphates. 4 makes 4 phosphates here. And I have 4 phosphates here. And then let's take a look. I have 3 leads on the left and I have 3 leads on the right, and then 12 and 12 chlorines. So my balanced chemical equation, okay, is right here. Okay, that's it. All right, go ahead and work this through. If you have any other questions, shoot me a message either on Google Class or send me an email.